NASA has officially announced that it will accelerate the development of a 100-kilowatt nuclear reactor on the moon. This news is not only a breakthrough for science, but also marks the start of a new space race on the global stage. The biggest challenge for establishing a permanent human presence on the moon has always been power. Unlike Earth, the lunar day and night cycle is completely different. On the moon, a single day lasts 14 Earth days, and a single night lasts another 14 days. That means solar panels can't generate power for half the month. On top of that, some regions at the lunar poles are in permanent shadow areas that contain frozen water but never see the sun. If humanity truly wants to build bases and cities on the moon, then we need a power source that works everywhere, at all times, under all conditions. And the only reliable solution is nuclear power. NASA's new project is designed exactly for this. Originally, the plan was to build a 40-kilowatt reactor, but now the power output has been increased to 100 kilowatts. The reactor will be compact, weighing under 15 tons, making it transportable by future rockets like SpaceX's Starship or NASA's SLS. It will use an advanced Brayton cycle power conversion system, capable of generating continuous electricity for lunar bases, habitats, communication networks, laboratories, and rovers all at the same time. NASA isn't working alone. Major companies are deeply involved in this program. In 2022, 3 major contracts were awarded: Lockheed Martin with BWXT and Creer, Westinghouse with Aerojet, Rocketdyne, and X-Energy with Boeing. These teams originally designed 40-kilowatt reactors, but now those designs are being upgraded to reach the new 100-kilowatt goal. But here's the other side of the story. This is not just about science, it's also about power politics. China and Russia have already announced plans to build their own nuclear reactors on the moon by the 2030s. NASA knows that whoever builds the first functional reactor will gain a massive strategic advantage. That's why the US is racing to achieve this milestone first, securing not just energy independence on the moon, but also the ability to establish keep-out zones around American lunar infrastructure. This is how the politics of outer space is starting to take shape. So what happens if this project succeeds? For the first time, humans will be able to build permanent lunar bases. Frozen water trapped in the lunar soil can be extracted and turned into drinking water, oxygen for breathing, and hydrogen for rocket fuel. 3D printing can be used to build structures directly out of lunar regolith. Entire habitats, research labs, and even launch pads could be powered nonstop by this reactor. And beyond the moon, this technology will open the door to Mars missions. Solar panels on Mars face major limitation. Sunlight is weaker there, and massive dust storms can block the sun for weeks or even months. A nuclear power reactor will allow astronauts to survive and thrive in such extreme conditions. This isn't just a power project, it's humanity's next giant leap. Building a nuclear reactor on the moon is a declaration that we will not remain confined to Earth, but instead are preparing to settle permanently in outer space. This could be the turning point that changes the future of human civilization forever. So what do you think? Is nuclear energy truly the key to human survival on the moon and Mars? Share your thoughts in the comments below. And don't forget to subscribe for more updates on space exploration, technology, and the future of humanity beyond Earth.